One machine's event viewer tells you a story about one machine. Tier 3 asks a bigger question: is this a one-off, or a pattern across the whole fleet? In this lesson you'll learn to query logs precisely and fast, build cross-source timelines to find the originating event, and aggregate across many machines with KQL to tell an anecdote from a root cause. Here's the mindset shift. At Tier 2 you read one machine's event viewer. At Tier 3 the question changes: is this a one-off, or a pattern across the fleet? A crash on a single laptop is an anecdote. The same crash on 40 laptops, all after the same patch, is a root cause staring at you. Scaling your log analysis from one host to many is the core skill of this lesson. The most common performance mistake is filtering in PowerShell instead of in the log engine. If you pipe Get-WinEvent to WhereObject, it reads and deserializes every single record, first agonizing on a big log. Instead use -FilterHashtable, which pushes the filter down into the logging subsystem, so only matching records are ever materialized. On a busy server that's often orders of magnitude faster. Filter at the source, always. Logs are full of symptom records. When one low-level service dies, dozens of components log that they lost a dependency. So the loudest, most frequent error in the log is usually a downstream symptom, not the cause. Root cause analysis means tracing back to the first, quieter originating event on the timeline. The cascade is noise, the first failure is your suspect. Don't get seduced by the error that simply repeats the most. A single log only shows its own components view, so correlate across sources. Merge the system and application logs and any device or security logs that matter into one collection, then sort everything by time created. Now you can read the causal chain across components and see which event fired first and triggered the rest. The event at the very top of that cascade is your originating suspect. This is the technique no single log can give you. When logs are centralized in a workspace, Kusto Query Language, KQL, lets you separate a one-off from a fleet-wide pattern. The key move is summarize with bin by time. Binning turns raw events into a rate over time, so a spike right at a deployment window jumps out. And summarizing by computer tells you whether one host or 40 are affected. That count, across the whole population, is the difference between an anecdote and a root cause. Two biases will wreck your log-based conclusions. Selection, or survivorship, bias. If you only investigate the tickets that got escalated, you're sampling a skewed subset, and a common problem looks rare. Confirmation bias, filtering only for the events you already expect, and never querying the rest. The defense against both is the same: always query the whole population and let the data tell you the true prevalence, not your assumptions. Recap. Filter precisely and server-side with FilterHashtable, not WhereObject. Trace back to the originating event, not the loudest symptom. Aggregate across the fleet with KQL's summarize and bin to tell a one-off from a pattern, and actively guard against selection and confirmation bias. Your task: pull service control failures with FilterHashtable, merge system and application into one timeline to find the originating event, aggregate by computer and time bucket in KQL or group object, and state whether it's a one-off or a fleet pattern. Next, RCA frameworks.